I'm here today to talk to you about the Android transition framework, specifically about the window content and shared element transitions. I know that there is also layout transitions, but those will not be covered in this session. But generally, after you learned about these two parts of transitions, you will know how they work and how to apply them within the layout transitions as well. My name is Ben Weiss. I work in London as part of the Android Framework Developer Relations team as an engineer. And I spend a lot of time on transitions. This is why I'm talking about this today. Because first of all, the main question that several people ask is, why should you actually customize your transitions? Why should you care for this? If you take a look at how this works from the Android system itself, you click on a view, and what you get is a nice fade in and slide auto transition. But if you add a little bit of extra work to that, you can easily guide the user to make this more appealing to the user. When you click on that, you have a nice growing, nice change bounds transition on that to actually show you where the user clicked, and the user knows exactly in the flow what's going on. This also can be, this is not only limited to just using one activity, but you can do this within fragments as well. This is a sample that we did called Our Streets, which is on GitHub, focused on fragment transitions. And as you can see, those work on several fragments that are being changed over time when the user clicks from one state to the other. Also, there's a third very advanced samples on transitions, which Nick wrote. It's called Plaid. And it uses a different approach than the other two samples from the UI perspective, but the framework that it uses, of course, is the same underneath. So these three samples definitely should be a thing for you to take a look at when you want to learn more about transitions in depth. And if you're stuck in some place, those samples are very helpful and prove very helpful to me as well as a point of reference. So let's get started with the basic principles of what actually is a transition. So think of your application as having different scenes, and a transition is the part that happens when you change from one scene to another. And it asks itself the questions, what has changed from one scene to another? And it animates those differences with a very straightforward API. It captures the start and the end values, and then creates an animation on top of that. There's several transition types. One of them is the content transition, which just transitions content as the scene is being changed from one scene to another. New content comes in, old content is being removed from the scene. There's also a shared element transition, which uses one element that is in the original scene and passes that to a target scene, which of course can also be combined in a shared element content transition. So you have the elements of both these transition types in there. Let's take a look how a shared element transition works in the first place. So you take a look at the source activity, and the view that has been clicked, the bounds of that, as well as a couple of other, a little bit more of information, is being passed through to the target activity. Then the Android framework looks for a view that matches the transition name. I'll come on that later. And then matches that with the bounds that are in the target view, then rewinds this information, makes a couple of adjustments on the layout, and then plays the transition so that the view is being, in this case, resized and moved to its final state. And then after that, in this case, fades in the information that has been in the content transition. So keep that in mind. There's a couple of things that will be passed in, not all of them. I'll cover that in a second. So when it comes to transitions, they come in pairs. There is a exit transition. So when you exit from one activity or one fragment, or from one activity or one fragment, you have the exit. On the other side, you have the enter. On the way back, of course, you have the return and the re-enter, which are your callbacks that you get from the window. You can use those to manipulate the transitions at whatever point you want to make it. But if you don't set a re-enter transition, what will happen is that the enter transition that has been played forward in the first place while entering this new scene is being reverted on the way back. So you get the, it's basically just like pressing rewind on a tape recorder. Same thing for the exit and re-enter transitions. So let's take a look at what you get for free from the Android framework. Let's take a short look in the Android transition package. It's not everything that is in the package I will cover here. I will cover the most important bits that you will be using in the first place when you start with transitions. One of the most used transition is change bounds, has been added in KitKat. It allows you to change the size and bounds of a view, which we saw earlier in the presentation already. Also, there is the fade, which manipulates appearing and disappearing of views. This is extending visibility, which you definitely should take a look at when you start customizing your transitions for moving views in and out of your hierarchy. Also, the auto transition, which is the fade in, change bounds, and fade out, depending on the state of your transition, actually. This is what you get for free from the Android system, the auto transition, when you don't call anything. When you don't do any transition at all, you actually have a auto transition going on. So in Lollipop, there were more transitions being added. There was a slide which allows you to enter and exit views from either side of the view by passing it a gravity attribute. Also, animations, transitions for clipping and image transformation were added. One of the things that is very useful is path motion, which in this case, very exaggerated. Please don't, if it looks like this, you probably didn't do it correctly. But what it does is it moves the view from one of the most popular is the arc motion, which moves the view in an arc, so applies some artificial gravity to it. Also the pattern path motion, so you can have views move from one point to another following a path, and even that within curves. Also in 21, the propagation epicenter was added, which is transitions for explode, and you can use those for having staggered removal and entry of views after a transition has been fired. And in Marshmallow, the change scroll was added, which allows you to change scroll positions depending on the changes within the views that you're transitioning from and to. So let's take a look at the properties you get for free. Basically, the views bounds, as well as translation Z and elevation, the width and height after it's been measured, and a little bit of information for the image is those are the things that you get for free from the Android system when you call a transition. If there's anything else you need to pass in, you have to pass that in manually, like text sizes and a couple of other things. You have to pass those into the transition when you call it. So not all the transitions that you actually call are being created in the same way, and they're not all equal, which can take a little bit of time to figure this out. This is why I figured it makes sense to have this in here. One of the important things you want to do is delaying transitions when you have views that are not fully populated, or not everything is already there when you start the activity and when the transition actually would happen. So what you do is you postpone a transition. Within an activity, this is straightforward. There is an API which just is called postpone enter transition. You postpone enter transition, then your activity is in a state where it just waits for another call to start postpone enter transition. This is the moment where you wait until all your layout has been set up, so all your adapters are being populated and your view is ready to be drawn, or there's a couple of other things that you could do. For example, when you have a view pager, that all your elements actually are being populated correctly as well. So the two listeners in that is a on pre-draw listener, which we'll cover later on, and also a on layout listener might be helpful in some cases. If you don't call this method, the start postpone enter transition, your activity will not really know what to do, and you will end up in a kind of limbo state, which it usually comes up, either the application feels like it's frozen, or sometimes you get a black screen, sometimes you get fragments on the, fragmentation of the view in there. There's various different things that can happen. So make sure that you always call start postpone enter transition after you call postpone enter transition. But if you do that, this is straightforward, the way it works for activities. For fragments, that is a little bit different. There is no API as such that allows you to do a postpone. What you can do is you can create your fragment, you add it within transaction to the, you add it within a fragment transaction, you hide it, you commit that, you do your layout and wait for everything to be ready, and then you show it. If you remove the original fragment and re-add that while everything's been laid out, you can actually do a shared element, but usually you can do just a content transition like this. Because when you want to add a shared element within fragments, what you have to do is you begin your transaction, and you have to call a replace or a remove and add within the same transaction to actually get the system to understand that there's one thing that's been removed and another thing that's been added for the shared element. And then you just say add shared element for all the elements that you want to add. You add them in there with the start view so the system can gather all the information it needs, and the transition's target name. So every transition, every object that can be transitioned to has to have a target name in order to being recognized by the system correctly. So shared elements for activities. There is activity options, same activity options compat, which you just call, and you call that with a pair that you add in there, which is the same information, so the view and the target name, and you can just use the var args there to add more and more and more of these elements. And pass that to the activity that you want to start in pass in the options as a bundle to the activity. So when it comes to passing in more information and holding on to information from a view, and a couple of other things like for the shared elements, the shared element callback is your best friend. It helps massively. And the two most important methods of that are on shared element start and shared element end. So if you start and working with a shared element transition and you don't know what's going wrong, just create a dummy shared element callback and add breakpoints on these methods and take a look at the names, elements, and the snapshots that are actually being passed. Snapshots are the least important in that, but the names and the elements, and see if actually everything is where it should be. So the cool thing is about the start and the end, they always get called, but for a activity transition, what will happen is they get called in the order. If you enter, they get called in the order start, end. And if you return, they get called in the order end, start. So the activity the transition is being reversed. This is what I talked about earlier. For fragments, on shared element start is called always in the first place. So whether you enter or you return, doesn't matter. Same thing for the shared element end is being called when you enter in a shared element transition for a activity, it's being called in the second place. If you return, then it's being called in the first place. Same restrictions apply for the fragments. Another thing that's pretty handy is mapping shared elements. We'll cover that later. That comes when you actually want to come back to a different view that you actually started off with. Sounds a little bit abstract, but I've got an example on that. And also unreject shared elements. So if everything's working fine, but one element that you don't know what's going on, have a breakpoint on this method, and you know which one's being rejected, and if you're actually correct that it's being rejected. Also, there is a couple of more methods, which are not being called for fragment transitions. But I haven't fully encountered why I would use those for my own applications yet. So if you come to that point, this is definitely a thing that you need to be aware of. As you can see, those are all way down when it comes to transitions in the documentation. But those are the four most important parts that I found when it comes to the differentiation between fragment and activity transitions. So let's take a look at how we actually can create our own transition, not just use the framework to apply transitions that are already there, but make one ourselves. Let's take a look first at the default animation that the system gives us for that. We have a fab in the one activity, and in the other activity, we've got the card view. As you can see, a custom transition might be more useful here because the user clicks on that, and what comes up is the card. You don't really have a flow that guides the user to what's going on, and they might get lost in that. This is a very abrupt break, which is intentional. So after we're done, this is what we're aiming for. So just a circular reveal and a circular conceal on the other end. So then the users know exactly they clicked it, and the content that they want to come to grew and shrunk when they come back. Since there's no transition for this circular reveal as it currently is, let's first take a look at the API that Android gives you for that. So let's fake it and make an animation. The steps that are involved is we gather all the information from the initial view, we add this to the intent extras, we handle it in the target activity, and then we animate the things that we want to animate. And on the way back, we rewind that. So how does this work? In the start activity, we just gather the bounds of the view, which are the parts that are important to us, and put those in the extras. And in the target activity, straightforward, we first of all have to override pending transitions to tell the system that there is no other transition or no transition at all running. What we're doing is an animation, and we don't want anybody to interfere with that. So all transitions are being disabled for this onCreate call. Then we get the information that we passed in, so the bounds of the view, and animate our circular reveal. The animation on that is started with setting the view to invisible that we want to animate to, so that there is no glitch in the first place, because otherwise, before this has been called, it might be possible that the view already has been drawn the first time. So what we will see is the card view already fully there, and then not contracting, but then being clipped to the floating action button size, and then having the transition going on. So first of all, we set it to invisible. Then we add the onPredraw listener. Within an onPredraw listener, or within anything that you want to do view manipulation, what makes sense is to the first thing you do in there is remove the onPredraw listener once the onPredraw method is called. Because otherwise, what will happen is in every onPredraw call, your code will be executed again, and you usually do not want to have this. In there, we set the view to visible, and then call the view animation utils and create our circular reveal with the target view, so the card that we want to transition to, and the x and y coordinates of the starting view, and the height and the bound, so we have the the reveal going on there. We then return true to have the draw pass continue. Everything's fine. Transition should work flawlessly. So let's take a look on the way back. So when you go back, so press back, or whatever, for whatever reason, finish the activity. Actually, you usually just don't. Only when you go back, you create a circular reveal again, but this time from the starting bounds from the card, and then going all the way down to the size of the floating action button. There's one thing that we need to do, since the bounds of the original view is the card. What would happen is on the way back, we would get another glitch because the bounds are not the same as the fabs bound. So what we do is we set an outline on that. So we use the setOutlineProvider method and set an outline to the fab size once the transition has ended. So once the animation is done. After that, we tell the system again there's no transitions running at all, and then start this. Cool, straightforward. Let's take a look at what this does. Exactly what we wanted it to do. Nice transition, or a fake transition animation that runs the way we want it to be. So from one way in, expands, other way contracts. Cool. Let's take a look what we just said. Yeah, nice animation, cool. Why should we do anything else? Yeah, our logic is bound to this one activity. There's no other place that we can use this. Okay, we could by copy and pasting, but please don't. This also bloats the code of your target activity and the logic that you have in there, and setting stuff to visible, invisible might be confusing after a while. And it's also not reusable, because, yeah, like I said, you have to copy-paste that or put that somewhere else. And there's no transitions running at all. So if you want to have something else going on than the shared element animation that we have in there, you would have to work around this even more. So let's go ahead and make a nice transition out of that. What do? We set up the app for transitions, then we create a circular reveal transition, and then we share the elements. The setup is fairly straightforward. You just say window activity transitions, set this to true, either within your app theme or within the activities that you're running this on. But the cool thing is if you either inherit your theme from Material or AppCompat, you get this for free because those have this already turned on in their themes. Then, for the view that you're transitioning to, you have to set a transition name. The transition name has to be unique for that hierarchy, because what happens is that the framework goes through the view hierarchy and asks who responds to this transition name, and the first responder of this to this question gets mapped to your starting transition. So you might get if you have multiple views with the same transition name, what will happen is that you might get the target transition to the wrong place. After we set this up, we create our transition. We override capture start and end values, since the values that we capture in there are similar for both ways. We just have one more method, which just captures the view values, the values that view, checks out the view, and takes the boundaries of that view, puts it into properties, and that's basically that. So all the information that we need is stored in there. In order to get a little bit more of the framework, so the cancellation and pausing logic, also that there might be no overlapping of transitions, you might want to consider doing something like this. So having a unique name for your property values that you actually care about, put them into an array and returning them as part of the getTransitionProperties method. If you don't do that, what will happen is that the transition will work fine, but at some point you might have problems when overlapping transitions are being run or when things are not being canceled correctly. So always worth just adding this in order to avoid this and avoid the problems that you might encounter later on. After this setup part is done, we gathered all the information, we start creating our animator. And being a good citizen, if there's no start or end values, we just return and let the system continue. We don't want to hog up anything else. Otherwise, what we do is we capture the start and the end properties and the view that we're working on and create the transition. Basically the same thing, the same code that we ran earlier with the view animation utils. We create the reveal or the conceal. How do we figure out which way we're running? Because this method is create animator. It creates the animator for both ways, no matter whether we're concealing or revealing the animation. We just check whether the start bounds are included in the target bounds, because we know that the target bounds, when we're revealing, are always going to be bigger, and the other way around, we know that the target bounds are not included in that. So on the other way, if we're concealing that, what will happen is we first of all have to lay out the target view that we're transitioning to use the initial bounds. So in this case, we have the view is the card view, so the big view. But we're so the view is the card view, and on the way down there, on the way down to the fab, what will happen is that sorry. Sorry. On the way back, what we've got in the, as you can see up there, the end values view is the fab, and we have to lay this out in the start values bounds. So we have the actual bounds that we want to go from. So the view has the clipping of the actual card that we want to come from. So we're going back to the fab. Otherwise, what will happen is that we're already drawing within the fab size, and the problem with that would be that the transition wouldn't really show. What we'll get is an immediate snap towards the fab size. It's not the right way that we want it. So we have to lay this out in the cards view, in the cards bounds. Then we create a circular conceal, same way we did it in the first place with the animation. And add the same way the clipping towards the fab size on the way out. So on animation end, we get the outline, get all the information, set the clipping there, and return an animator. In this case, this is a specific case because the circular reveal is being run on the render thread. Usually you would just return the animator that you created. But in this case, you have to create a no pause animator, which just catches all the pause calls and just doesn't care for them, because otherwise you would get some exceptions that you don't want to, that you want to avoid. And take a closer look at the a blog post from George Mount on this. So if you type no pause animator George Mount, you will definitely find some more in-depth information on why this is particularly handy and how the code for that actually looks like. It's straightforward, just just overriding this. After the transition is done, what we do is we share the elements the way we did before, just create the activity options and pass in the fab and the card view for the target, the name for the target view, pass that to the activity. And in the target activity, what we do is we set the shared element enter transition to be our circular reveal. Cool. I don't see any difference. That is perfect. That's exactly what we wanted to have. Again, we get this nice animation. Cool thing is it's reusable everywhere where you can use your transitions. It's not just for a shared element transition, but you can have this wherever you want to use transitions. You can just call your circular reveal. Can be extended if you want to. It's a single point of responsibility, and you can have all the other transitions with that as well. So you're not limited to just having one animation running, but can have change bounds or fading of other content on that as well. Cool. So after we created our transition, let's take a look at a couple of things that are less common as far as I've encountered them, but are fun to do with anyways. But before we do that, one of the things that I've found and I've heard that can be a little bit tricky when it comes to transitions is wrapping your head around it. One of the things that you have to do is think about the way you choreograph your transition. So what I usually do is I write down what I want to do. I've got a couple of steps in here. Just say, the first step is I want to move the click view to a target position, and then I want to resize it while this happens. Then I want to remove all the other elements of the screen, but this should be simultaneously. So this is the first step of this transition. And on the second step that will happen is the new content will be slid into the new scene. So two distinct steps. What do we have to do? First of all, we create a shared element transition, which uses change bounds. This is the first step, which will have to be done within the way we just saw that. Then we want to exit the rest of the elements, which is a window exit transition. So this is a window exit transition. So those are two different parts already. So two transitions that we're working on. And the third part on that, so the second step, is the sliding in the content that is new to the new activity. Now that we know exactly what we want to do, we know that there's three distinct parts. We have the shared element transition, we've got an exit transition, and we've got an enter transition on a third part, on a third view that we want to work on. So now we know that, it's easy to actually get your head around how to put this in code. So one of the things that I haven't shown you before with the transitions, just because I turned off a feature for that. So we didn't want to draw the window decorations ourselves for the sample that I had in the first place, because otherwise what would happen if we have if we draw the window decorations ourselves, what will happen is you see that the status bar is being moved in with the rest of the content as well, and that is usually not a thing that you actually want to have. How do you account for that? Either within your transition, you just say you want to exclude these IDs. These views, if you have them within your hierarchy, you're able to do a lot of things on them. You can put colors on them. You can they have transition names, so that's another thing. But you can do this in code as well. You can add them as part of your shared element transition by just getting the decor view of your view that you're working on, getting the status and navigation bar drawer. Be aware that not all devices have navigation bars on screen. So make sure that you check whether this device that you're running on actually has a nav bar or not, because otherwise you will get crashes from that device because it doesn't find the views. Then you just get the transition names of that, put them into the shared elements, and there you go. You can use them as a part of the shared element transition. Or, yeah, like I said earlier, you just turn off the draw system bar backgrounds. You don't want to do this. Have the system handle this. Cool, because it makes this easier. You don't have to take care of this, but you can't recolor them. You can't do all the fun things on the backgrounds that you could do otherwise. Let's jump to another thing. Orientation changes, yeah. Always fun to work with them. Important to do that, especially when you want to have survive orientation changes for transitions. So this is what we're planning to do. The system usually wouldn't do that. What would happen on the way back? The system couldn't match the target, so it wouldn't transfer back, wouldn't transition back. But you would just get the fade back. So, but we want to have a nicer transition on that. So let's take a look at what we need to do. We first have to make sure that we have unique IDs, then save the states of the information that we want to share, that we want to be available again, and then we postpone the transitions. Since in this case we are worried about the way we're coming back from a transition, we have to make sure that the starting view is unique. Data binding is amazing for that. You can do it in other ways. So you can do in on-bind view, on-bind. You can do that. Have some unique part in there, but it always has to be reproducible because that's the information that you pass in and pass back. Then you just save the information. In this case, I just save the photos because the photos are it's not the actual bitmaps, but it's the information that is associated with those. So I don't have to load them from the network again. That makes the restoration process a little bit faster. And in onCreate, what I do is I just get this information back. But before we actually do something on that, we postpone the transition so that the system knows that we want to do something before you actually run the transition. Please, let me finish this. And then once this is done, we add the, in this case, a view tree observer we add the view tree observer at the onPredraw listener, and then remove that and start the postpone transition. Pretty cool, pretty straightforward. There's also another thing that you can do, which is where on map shared elements it comes in handy, which is remapping. Remapping basically is the process of just changing the actual target that you had in the first place to a new target that you want to come back to. So this works by requesting a result from the target activity that we're going to, then updating the position that we want to do, that we have that has been selected, and then digesting that result and remapping the elements. So how does this work? Cool thing is the Android framework already has that in place for just saying start activity for result with a request code and the bundle. So we pass in the request code, and once we're finished with the activity, on the way back, we either, if the item that has been selected still is the same, we don't do anything, we just say, please continue the way it was. Otherwise, we add the selected position on the way back to the intent. And then this is where the method onActivity reenter comes in handy, which is being called in particular case. So if you started the activity for result with the bundle that you passed in the first place when creating the activity options, this is where this method is being called. First thing there is you postpone the enter transition again because we want to do some work on it. Then we add the predraw listener again, wait for everything to be set up, and then we start transition the way we did earlier. But this is not all, because what would now happen is basically not a lot. We know that there has been a different item that has been selected, so this is where we set a shared element callback, and specifically on map shared elements. What we do there is we first of all remove all the elements that we don't really care for. So all the elements that are not part of the share of the new shared element, and then we map the new shared elements. So the elements that have been just passed back to the activity. Again, this is what we get from it. Pretty straightforward, nice if you do it, and a nice transition that keeps the user informed on where they're coming from, where they're going to, and how the hierarchy of the whole system works in your app. That is all from my side. Thank you very much. And these are all the samples that I used for this presentation. So
will the slides be available anywhere?
I don't really know right now. But video definitely will be available. If the slides are available, I'll just put them out on on social channels as well. So yeah,
Okay, cool. Thanks.
welcome. Yeah, questions? Yes, please.
So in our app, we make pretty heavy use of the shared element callbacks.
Yeah.
And then when we launched it, we saw some crashes sort of in the framework in the transition coordinator only on 5.0.
Okay.
But not on 5.1.
Yeah, there were bug fixes. So yeah.
Are there any known workarounds or reasons that cause some issues on the 5.0 that we can potentially use?
Can you just repeat the question?
Oh yeah, sorry. The question was if there's no issues on 5.0 that with the shared element callbacks and the. I'm not aware of the issues as such that you encountered, but we can just take a look at that. And what I would recommend is just take a look at the source again and make sure that you somehow make sure that these issues don't encounter that you work around those issues. I'm not sure. I'm not aware of any specific issues right now on that because I usually just work on the latest available versions of Android for that. Sorry. So yeah, we can take a look at that later. I'm here for all droidCon, so I'm happy to help you out with that. Cheers. Questions? Yes, please.
You talked about the active differentiations and how fragments.
Yeah.
In our app, we actually have fragments within activity we want to transfer to another fragment within another activity. Is
Okay.
that possible with the random transitions, or is it
Yeah.
no big deal?
That is generally possible. You might have to set a couple of delays and postpone the transitions, so the fragment actually is inflated and everything's already set up. But that I don't see any problems why this shouldn't work.
Wait until the fragment is attached and to
Yeah.
actually
That has actually been laid out and actually everything is already set up to being drawn. That's the one thing that you have to wait for. So postpone enter transition is your best friend in that case. Yeah, if you have further questions, feel free to just approach me later on. I'll be here all the 2 days. Thank you very much.